I'm CK, and tonight, once again, you have a better idea what I'm going to build than I do, because you've seen the title screen. It's a bag from Thonk, and I forget what I bought. I bought like 5 modules a couple of weeks ago, and this is one of them, and I don't remember what it was. But we'll put it together, see how it sounds, and I hope you enjoy the video. Let's see what's in the bag. One package here. Oh, here's a, well, I guess it's a couple of things. It's a AtoVproject from Germany. Not familiar with what that is. And the other one is a Divergent Waves from Gloucester. It's a dice kit. That's something. I think I'll do this one. We'll do the AtoVproject out of Berlin. It's black cover. It looks like a it's got a VCA in it, a VCF in it, and it's got a frequency knob. I honestly cannot remember purchasing this, but that's not unusual. I kinda go on Thonk and just poke around looking to see what's there, what might be interesting. It's got a that was on the other one. Never mind. Let's see what's in here. Take all the bits out, and then we'll look at them individually. So I guess it's a all-in-one VCA. Oh, look at that. Okay. It's, I have to move this because the camera's trying to focus on that. It's all much surface mount componentry already pre-installed. So that's too bad. That means there's less for us to do. I wonder what's in this little roll-up. Maybe nothing. Maybe it was just, no, there's something in there. Pull it open, and it is a, oh, well, that's uninspiring. It's a couple of screws to mount it in the panel. Power cord, a couple of knobs, simple knobs, no set screws, plastic. Let's look at the front panel, even though they had the picture of the front panel on the outside of the box, so that kind of gave it away for us. cDVCA. Now, obviously, it does more than it's got a filter in it too. Frequency for the filter, drive for the filter, and VCA. I'm not real sure. We'll have to play with it. Actually, I'm gonna once we look at the parts, I'm gonna bring up the build guide and see what this actually is. Wow, parts. 2 pin headers, 4 pots, 6 jacks, 2 trimmers, and 2 LEDs. So this will be a quick kit this evening. Making sure there's nothing left in the bag. These are interesting pots. They're probably the least expensive metal pots you're going to find. A couple of trimmers, a couple of LEDs. Oh, these are interesting LEDs. They've got a, let me get a better background. They've got broad shoulder and a long light pipe at the end. Let's see what color these are. just for fun. Get my meter, turn it to continuity mode, like so. Red, black probe on the short lead, red probe, and they are white. That one's white. This one is probably the same, but I'm not going to assume that. Yep, that's white also. They could be multicolored, different voltages, but they, on first glance, they're white. So that's the parts. Holy Toledo, why is my light on my camera all messed up? There we go. I'm still adjusting this from coming back from my last trip to Antarctica. So that's it. Let me get the soldering iron heated up, and I will pull up a build guide or some documentation on this so I know what the heck it is, besides just a VCA. And we'll put it together. This is an interesting little module. It's a, you can go to their website and read more detail. I'm going to go over it very quickly. This controls an internal oscillator, triangle oscillator, that goes all the way up to, I think it's 34 kilohertz, and then all the way down to, I think, 6 hertz, something like that. So what happens is if you put an input in here, an audio input, that sine wave is going to be matched with this triangle wave, or compared with this triangle wave, to create a pulse wave, and then it goes through the voltage controlled filter to smooth it and bring it back to a sine wave. So obviously changing this frequency, varying it, say with an LFO or whatever, is going to create interesting sounds. If you don't have anything going in, and bring this down to the lower ranges where it's an audio from, you know, up to 20,000 hertz, it can work as a simple oscillator voice. So we'll play with that. And then of course there's drive for some distortion and some other things. So it's an interesting little concept, and again, very, very simple to put together. Let me bring up the build guide. They actually have a build guide for it, and primarily because you want to be able to calibrate it, even though they are quick to point out this is not a oscillator that you're going to rely on for precise tuning. There's no temperature compensation. There are other things that are missing for that. This is really designed to be a wave shaper and interesting sound design tool, which is pretty cool. So the first thing we're going to do, and by the way, the build guide is good for a very, oops, wrong part. For a very small kit like this, they go into a lot of good detail on how to assemble this with good pictures, and I certainly appreciate this. As always, when you're working on a board that already has surface mount components installed, be very disciplined with your soldering iron use. Use a small tip and don't touch the surface mount components, and as important as not touching the components themselves, don't get your soldering iron too close to the solder pads that are holding the surface mount components on the board, because you can overheat, you can heat those and create, sometimes you can slide a component off its solder pad and you won't even notice, and then you'll be sad because the unit will not work well and you will have no clue why, and it's not visually evident that a component might not be surface mount soldered anymore. So just be real careful with that. Then we'll just put all the front parts on, and we will, I think all the pots are the same. Yep, clank, clank. They're all 10K, it looks like. Yep, they're all 10K, so we don't have to worry about getting them in the wrong place. Trimmers have good into their 3-pin offset, so it would be darn near impossible to get them put on the board wrong, though I will say humans have wonderful ingenuity in getting things wrong. Small positive symbols on the board for where the LEDs go and how to position them appropriately. Everything fits pretty snugly, which is nice. Let's put the panel on. Panel goes on nicely. It's well fitted. I'm going to put one panel nut on the frequency knob. Let me see if my Bafaco tool works on this, because they've got notched black panel nuts, and it does. That's nice. So that's holding everything in place. I'm also going to solder one pin here on one of these jacks, applying pressure so I know it's as tight as it can be between the circuit board and the panel. Now I'll put a panel nut on that jack. And I just had my little, there it is. So now it's held on two corners, and I'm going to go ahead and put solder most of the pins. I'll do the LEDs last. One thing they do point out, let me read it to you. Down here there are some pins that are close to each other, but they're ground, so it doesn't matter if they bleed over a little bit. So I'm going to put, let me flip over to the side of my solder helper with the holes in it. And I can't get a good hole. That's good. And I'm going to go ahead and solder all these up. So that's all the soldering of most of the components. Now we're going to do the LEDs, and we don't want the nose of the LEDs sticking out, so we will put some painter's tape over the hole on each side. On there, tear this off. Oh, come on. Tear this off, put it over there. Now we'll push the LEDs into the holes, and the tape stops them from going further than beyond the face of the panel. And we'll put the rest of the panel nuts on. Get the knobs, and the pots have flat-sided shafts, so you can't really get them wrong. All the indicators, index lines should be pointing the correct way. Now it's not a keyed connector on the back for power, so we want to make sure the red stripe is where it's indicated red stripe on the board, like so. And that's it. Very quick assembly. Everything moves smoothly, so there's the front, there's the side with the two trimmers, there's the back, the other side, top, and the bottom. Now we'll do some calibration. So let me get set up for that. So I've got it plugged into my benchtop Frequency Central Route Master, and we're going to go ahead and check the frequency we're going to, the LEDs aren't on. I guess they're not supposed to be on right now. I don't really know what the LEDs do. So I'm going to kind of center that pot. Let me see if I can get a feel for it. Actually, one of the LEDs is on. So that's interesting. So that looks about centered. I think when I'm using it in my rack, that will be what I go to for center. So we're going to go to the ground point on the back here. Let me move this up a little bit so you can see it. And then go to test point 2, and that's 58, 57, 56% duty cycle, 55% duty cycle. So we're going to, that should be at 0. So I'm going to tweak this down a tad. Might be the wrong way. And that took it to 58, so that was the wrong way. See how that looks. That's 51. And again, we're shooting for 50% because it's at the center of, the pot is at its center position. A little more tweak, just a 1/8 of a turn. And that, oh, look at that. 49, I saw an actual 50. So we're dead on as accurate as I'm going to get it for that. Let's see what we want to do next. Okay, you can use an oscilloscope to do the same thing. With an audio interface, you can do the same thing. Then volts per octave. Now, important notes. The cDVCA is not designed to be an accurate oscillator. The tracking will not be perfect over the whole range, as there's no temperature compensation, so it'll drift. I'm going to put it in the rack. We'll turn it on, and I'll do a rough calibration of the frequency and see what we can do. But again, because it's not, the oscillator side of it is not the point, the wave shaping is the point, so I'm not really too worried about the exact tuning on that. So I'm going to put it in the rack and we'll turn it on. Alright, we're in the rack, and I'm going to screw the top on my can of Knurlies because I used 2 of them. But if you don't screw the top on your can of Knurlies, you're going to drop them and you're going to have to pick 100 Knurlies up off the floor. Okay, so we're powered up, and again, I'm not going to do voltage tracking calibration on this. I don't really care too much. I may tweak with a little bit. I've got my screwdriver in case I want to. But let's see. Again, we'll just start very simply. Frequencies all the way up, so that's about 32K outside of most human hearing range. And I've got my little amp up a little bit, so we drop it down. So that's the pure, raw output, whatever you want to call it. And there's the filter. I'll turn the VCA down a little bit because that it's an attenuator, basically acts like a volume control. Take the drive all the way out, turn that back up. Now, that's not the point of this oscillator, obviously, even though I'm gonna see what we can do. I'm gonna put MIDI keyboard into the frequency button, or no, I'm not hearing anything. You have to go way low to get it into the frequency range here. So that's C to C right there. I'm going to get my little tuner out and see if that's even close. I'll turn that down while I'm looking for my tuner so it doesn't bug the heck out of you. So that's showing a B4, that's a C sharp, C4 sharp, and that is, when I go up an octave, it's a B4. So I can tweak that a little bit, and I got to make sure I tweak the right one, because I want to show do what I did wrong. Okay. It's the bottom one. So I'm going to try and tune this to an actual C. That's close enough. Okay, so now we've got it roughly tuned. Again, the tuning is not going to be perfect on this. It's not intended to be. So I'm going to take that back out. Now we're in here. Now I'm going to do something. I'm going to take the output from my even VCO, which is sounding like this. Oops, let me bring that up a little. And go over to my put volts per octave on my even VCO. So you can hear it raw. So that's the output there. Now let's put it through here. I'm looking for which cable I can move from hither to yon. Now we'll put this as the input here. You can hear a little flutter. Now I'm going to change the frequency. I'm going to take the drive all the way out for right now. Now add some drive back in. Do some filtering. So that sounds interesting. Turn the drive all the way up, all the way down. Okay, next thing I'm going to do is I'm going to put my LFO going real kind of slow right now into frequency and see how that sounds. Let me turn it up a lot. It's too much. Let's go real slow. Okay, that's interesting. That's fun. Let's put that LFO into drive now. So that's all single note stuff, by the way, so I'm going to go ahead and go away from the MIDI keyboard and do CD from my sequencer. Going to go into drive again. Now I'm going to try the filter. So in the VCF, that's just varying control volume, basically. So that's what it does. It's an interesting unit. That's a fun thing. It'll be fun to play around with this to get real specific sonic textures. I'm going to take the drive out of that, take the frequency off the LFO. Actually, I'm going to put drive back in. Oh, listen to that. That's nice. Hear that? Oh no, there's a lot of potentials in this unit. And again, it was a very quick build, as you saw, and straightforward, simple build. This is a great first or second module. And it sounds pretty neat, and we can play with this a lot. I hope you enjoyed the video.